Hello world, welcome to the Berry project. I'm Mate, I'm the creator and developer of this new little programming language called Berry and its development environment called Dagger. What you see here is the landing page of the website of the project. If you go to the blog section, you will find this welcome blog post that this video tries to complement with some demonstration material. If you press on the play link, that takes you to Dagger, the development environment, immediately, and here you can start to type and write code immediately. In this case, I've chosen to write 1 plus 2 and a little eval operator that injects the computed result into the source section. Now, if you try to introduce a new programming language, you first have to answer the question, what key innovations you are bringing to the table of already established programming languages. In Berry's case, if I need to choose only one such innovation, that would be the user experience. In short, Berry tries to look like, feel like, and act like a computer game. By this, I mean that we are trying to fulfill three basic expectations that we take granted of computer games. The first being flow, that we are able to run, inspect, and modify our game world in a continuous manner without breaking the flow of the game. The second is freedom. By that I mean that the user can do whatever they want. It won't break the flow of the game. Maybe the consequences of their actions, the user actions, is not leads to the outcome that they are expecting, but it doesn't break the flow. And the third is function, that to play a computer game, we only need the computer game. We don't need other tools or other interactions. Again, we don't need to break the flow by jumping to some other tools. To demonstrate this very shortly, let's jump into this little implementation of Conway's Game of Life. Start it, so it starts to execute, and we can inspect, we can see the result, and we can modify the game world while we are executing and inspecting it, and we stay in the flow naturally. Why I've chosen Conway's Game of Life is because it's a Turing complete machine. So it's basically a programming language which can express any imaginable computer programs. Berry doesn't try to be a game which you can also program with, like Conway's Game of Life or Minecraft, for example, but Berry wants to specialize in programming. It's optimized for only this task. Since Berry tries to feel like a computer game, it was obvious that it have to be implemented as a computer game too. Now, these are the three main sections of the user interface. This is the source. This is, if you want to stick to the analogy, this is the game world. This black line is the inspect line. If you move over with the mouse in the source, the inspect line will tell you very useful information about that part of your code. And this third line under the inspect line is the edit line. This is where you edit the line you're at. You can go up and down to select the line for editing. Oh, I missed the T here. So, this is your game interface if you want, and like every computer game, Dagger is built around a main loop or a game loop. The game loop consists of 5 basic steps. One is keyboard, handling. The second is parsing, that we interpret the strings you type here and make some sense out of it. Then we need to swap. That means that before you added or removed a character from your input string, it had an old state and we have a new state after editing, and we need to swap the old state with the new state. Then we need to evaluate the entire source to be able to render it, and then we render it. Now, keyboard handling is kind of straightforward, but parse needs some explanation. The source is your game world, and what you do is you add ideas. We don't add cells like in Conway's way of life, or don't add blocks like in Minecraft. Here in Berry, you add ideas to your world and you build an idea tree out of these ideas. So in this case of this simple input of 1 plus 2 evil, what happened is the parser parsed it into a tree like this. Which tree can be evaluated, so it can calculate the end result. But also what's interesting, that it's the source of rendering the source back. In Dagger, we never store the source code in a textual form. Instead, we are storing it in tree form, but we are able to render it back onto the screen. And the flow stays fluid. We can add a new, in this case it's a label idea, which gives a name of a point on the tree, and we can add new lines. For example, we added a second line where we referenced this A label, so we created a list and we put an other branch into that, and this is a multiplication. With the reference and a num idea of 3. Since this is rendered from the idea tree, this part, you can always go over any ideas with the mouse and see what that idea is, what it consists of, what it evaluates to. It's also worth stressing that evaluation is part of the loop, so it's not the eval operators that evaluates the thing. We can go over this multiplication mark and see that this is already evaluated, despite it doesn't have evaluation. The evaluation operator injects the result and lets you see the result constantly. So if you put back the eval here and let's multiply this by 3, and we can see that the results is constantly updating. This architecture let us achieve the flow that we are running, inspecting and editing the program in a continuous manner, like in a game. Our second expectation towards game is this freedom thing, that whatever we choose to write, I try hard to input some garbage here, is interpreted. It doesn't break you out from your flow with a syntax error. It basically doesn't say that's something that you just cannot do because it's break the system. Instead, it makes whatever it can out of your input. This leads to some very interesting behaviors. Like for example, here is I start to write a list of numbers and I forget to put the closing parenthesis behind this sublist. But when the system interprets this line, it reaches the end of line and it closes any open parentheses. So when it renders back, the closing parens is there because we are rendering this from the, not this tree because this is the third line, but you got the gist of it. Since we are not storing any line in string form, when I go up one line to edit the second line and come down and the system produces the line in string form back to the edit line for me to able to edit, the parenthesis appears because we are recreating the edit line from the AST in a format called the Berry standard notation. What you see here is Berry standard notation because whenever we render or whenever we serialize a part of the tree, we use Berry standard notation and nothing else. So the code kind of heals itself. From this architecture, it follows that the system behaves like its own formatter, or prettier, if you will. So there are no syntactical errors you encounter while using Berry, but there are situations where a part of the tree cannot be evaluated because of some circumstances. So let's introduce third line with 10 by 5 and then do a calculation with that and evaluate the result. And let's say that we make a mistake and put a 0 here. That's a division by 0 that cannot be evaluated. When the system encounters such a circumstance, it jams the tree. So at this point, the tree realized that it cannot evaluate, and instead of a num idea, it produced a gem idea of division by 0. We can put an eval mark here too. And that gem propagated over towards this line because we referenced B here. What's important to understand that nothing, no part of the tree is jammed which is not part of that tree. We can see that other parts which are not affected by the gem are working just like they did before. So not having syntactical errors doesn't mean that the system cannot handle these circumstances. The third expectation was functionality. This whole demonstration demonstrates that I never left the environment for an external tool. Now this tight integration of all the functionality we need to interact with our programs might raise the questions that this might be limiting because I have to give up all the vast amount of tools already developed for plain text manipulation. But this is not the case at all. Since we are able to render the AST, we are also able to output plain text from it. So with issuing the download command, I can save this BSN file. Again, BSN stands for Berry Standard Notation. And here is the file I downloaded, shebang BSN. It's the exact same source what we've seen in Dagger, and I can edit it, save it, and then reload it. and it includes all the changes, and it re-evaluates, of course, after it parsed the BSN file. What this means is that the Berry standard notation acts like JSON acts for JavaScript. It's a serialization format, but it's not limited to only data as JSON do. It can mix data and code and serialize it one-to-one with the AST. In other words, text is an interface and the serialization format you can store or send over the internet. Of course, I have so many other things to say about Berry and Dagger, but I wanted to keep this welcoming video as short as possible. Please read the blog post. I will include the link to it in the description. And thank you for listening, and see you next time. Bye.